Alright, this video is our first video on logs and exponentials, and it basically is introducing the question of what is a logarithmic expression. So that will be the first thing we'll be looking at. So you'll be seeing these expressions. We call them logarithmic expressions, obviously, because they contain this word log here, but you'll need to know what that means. So let's talk about some of the words that came up in the last video, and some of those words were base, which is this little number here, and this number, it looks like a power, but it's not. So it's important to get your head around this, that this is not a power, this is actually your result. So in the last video, we looked at some common expressions that you would know, like the fact that 5 squared equals 25, and the base and the power go together. But in a logarithmic expression, they don't go together. The base sits next to the result, and the result is in the same line as the log. And the 2, the base in this case, sits a little bit lower. Okay, it's a bit lower down compared to the log and the 8. So if you're wondering how to write these sort of expressions, it'll be log for log, and then the base, whatever it is, I'm going to write this algebraically, so I might write it as x, a lower base, and then the result will sit in line with the log. So the base is 2, the result is 8. Logs for me always ask a question. The question is, if I have a base of 2 and a result of 8, well, what was the power? The power is actually the answer to the logarithmic expression. It's saying if I have a base of 2 and I want to end up with a result of 8, what power do I raise the base to? Well, hopefully you know that 2 cubed is 8, and so the power you would raise 2 to get 8 is 3. So when I am doing questions on logs, I will often join this to the result with an 8, and I'm thinking, well, what do I raise the 2 to get the result of 8? And so it's a little bit different. This is actually called exponential form. Okay, so exponential form is where you have a base raised to a power and then the result is on the other side, and this expression here is called logarithmic form. So here's a few examples. We've got all these expressions are clearly in logarithmic form because they have the word log, and what that means is over here, if it's in logarithmic form, then basically every time I'm looking for the power, I need the power that changes this base to this result, this base to this result, this base to this result, this base to this result. I hope you're getting the idea. So to go from 10 to 100, I would need a power of 2. So I raise 10 to the power of 2. In fact, it's a good idea to draw what I call this little circle where we check that does 10 squared equal 100? Oh yes, it does. That means I'm correct. So if I want to go from a base of 10 base of 100, a base of 100 over to 10. Now this is where you need to be good with your index laws. Hopefully you realize that's the process of square rooting, and the operation of square rooting has a power of a half, and then I can check it again. 100 to the power of a half, that makes me think about the square root of 100 is 10. So here I'm going from a base of 10 to a result of 10. I haven't changed. The only power that does that is 1. So if I check that, 10 to the power of 1 is 10. Yep, it works. Here's another one. To go from a base of 10 to a result of 1, I'm going to think, well, what do I raise the base of 10 to change to 1? Well, the only power that will change me to 1 would be a power of 0. And I can check it. 10 to the power of 0 is 1. Here we are, one more. To go from 1,000 to a base of 10, think about what's that operation to, and we're not multiplying. I find that sometimes students will say here, oh, now we multiply by a tenth or 100th or something like that. But we're not multiplying, we're raising it. And hopefully you know that to go from 1,000 to 10, that's actually the process of cube rooting. And cube rooting, in other words, the cube root of 1,000 does equal 10. To cube root, we learnt with index laws that would be a power of 1/3. So if I double check it, 10 to the 1/3, not 10, sorry, 1,000 to the 1/3 is in fact 10. All right, let's have a look at this example. If I want to go from a base of 10 to a result of -1, how do I do that? What power do I need? So I want you to think about this. If you have 10 and you start raising it to powers like 1 and then 2 and then 3, and then 4, that would give me bigger and bigger numbers like 10, 100, 1,000, 10,000, and so on, a million, a billion, and so on. So what about if I raised it to the power of 0? Let's go smaller. That would give me 1. And what about if I raised it to the -1? 10 to the -1 would give me 1/10. Right, darker. That would give me 1/10. And 10 to the -2, that would give me 1/100th. And 10 to the -3, that would give me 1,000th. And 10 to the -4, and you can check these on your calculator. You put that into your calculator, you should get 1 on 10,000. If you get a decimal, hit S to D. But what you should be seeing is I keep getting these fractions. And if I keep going 10 to the -5, 10 to the -6, I'm going to keep getting fractions. But none of those fractions are negative. So how do I raise 10 to some sort of power and then get a negative result? Well, the answer is you can't. This has no solution. There is no power I can raise 10 to that will give me a negative result. And so sometimes a logarithmic expression actually doesn't have a value. So you need to be mindful of that and think about, well, is there actually a power that I can raise this base to get this result? And if there isn't, you can write there is no solution. So let's have a look at, here's some for you to try. You can pause the video and try and figure out the power. Notice all of these are written in logarithmic form. So if they're written in logarithmic form, then the answer is always the power. It's really important you understand that the answer is the power that I raise this base to get this result. Okay, so once again, this is your base and this is the result, and it's the same thing every time. We could actually color code all the bases in green, base, 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 and base, and then we'll change over to another color with the result. So I want to go from the base to the result, and your brain's thinking power. What power do I raise these to? So pause the video, give a go at finding out the power, and then unpause, and I'm going to write down the answers. All right, 4, well, I have to cube 4 to get 64. And I can check it by, once again, doing that. I call it a circle. 4 cubed equals 64. It's like you're going around in a circle. So to go from 2 to 16, I actually need a power of 4, because 2 to the power of 4 gives me this result of 16. To go from 5 to 125, you actually will cube 5. 5 cubed is 125. To go from 25 to 5, that's actually square rooting, and square root is the power of a half. 25 to the half is 5. To go from 8 to a result of 2, that's actually the same as cube rooting 8. And hopefully you remember that the cube root is the power of a third. 8 to the 1/3 is 2. And lastly, to go from 3 to 0. Now this takes me back to that last video where I talked about if you raise, not last video, the last slide, if you raise 3 to lots of different positive powers, you're just going to keep getting bigger and bigger. And if I raise 3 to the 0, I do get 1. Don't confuse that for this, because don't forget, that's not a power, that's your result. So I get 1 by doing that. And then if I start raising 3 to negative numbers, all I get is fractions. I'll get a third, I'll get 1/9, I'll get 1 on 27, and I'll keep getting positive fractions. But firstly, I don't get a negative result. That's what we realized on the last slide. But also, I don't get 0. And so this has no real solution, meaning there's no real number on the real number line that will give me a power such that I can change a base of 3, I can raise a base of 3, to this number and get 0. I just don't have a number for it. So just to sum up, we now know what a logarithmic expression looks like. Okay, we have this number here called the base. And then we have another number, sometimes an algebraic expression, but for now we'll look at just numbers. We have the result. And the tricky thing to remember is that is not a power. Okay? So when we ask you to evaluate a logarithmic expression, we're asking you 9 gets raised to what power to become 1/9? And the power is what goes on the other side. That's actually the answer to the logarithmic expression, the power. Do you know what power we raise 9 to get 1/9? Hopefully you can remember what power that changes a number into its reciprocal is -1. And so the answer to this expression is -1. This way of writing it is called exponential form. So exponential form is probably the form that we're used to, where you have a base and it gets raised to a power and then it is equal to a result. And logarithmic form changes that around a little bit, where we now have the base and the result together, and on the other side we have the power. I hope this makes sense. Re-watch parts of the video if you need to.